The height h of a projectile fired into the air after t seconds is given by this equation, where h is measured in feet and t is measured in seconds. How long will it take this projectile to attain its highest point, and how high will it go? In other words, find the vertex of this parabola. The vertex is the highest point, and this is a negative in front of the squared term, so it's a parabola that opens downward, and its vertex will be the highest point. So let's find the vertex. So the t-coordinate of the vertex, in this case it's like the x-coordinate, only it's t, is negative b divided by 2a. In this case that's negative 888 divided by 2 times negative 32.2. And let me calculate that. And what I get for this is about 13.7888 1987 758. That's how many seconds to attain its highest point. In fact, when we round that off to the nearest tenth, we'll have the time. So the time t to get to the highest point is about 13 point, to the nearest tenth. The 8 will cause us to have to round up to an 8 there. So there's the first part of the question. It'll be about 13.8 seconds before the projectile attains its highest point. How high will it attain? Let's plug into the equation for h to see how high it'll be. It's easier if you factor out a t, by the way. If we factor out a t, the calculation is a little easier. So we have negative 32.2 t plus 888. I factored out a t. There's a t here and here, so there it is factored out. It's just easier to compute when it's factored out. Now we're going to substitute this value we just found for t into those positions, and here's what we get. Let's see. So we have 32.2 times 13.8, only negative now, and add 888 to that, and then multiply that times 13.8. And what I get is that this is equal to 6,122.232 feet. And if we round off to the nearest, just to the nearest tenth of a foot, we can truncate it there. So the height, the maximum height, is about 6,122.2 feet. So that's the answer to the second part of this question.